Hi, Calc. Hopefully you understood and followed along and enjoyed Mr. Engel's quick presentation and introduction to this chapter. So what are we trying to do this chapter? We are trying to take a look at something that is not a polynomial and find some polynomial that could closely resemble the graph, the equation, and all of that of our non-polynomial equation. Why would we want to do this? Because polynomials are easier. They're easier to take derivatives of, they're easier to take antiderivatives of, and they're just easier to work with. So for example, take a look at this guy. This is a rational expression, okay? But something about that rational expression pretty closely mirrors what we did last chapter with the geometric series. So what are we going to do with this? We are going to try to get some kind of polynomial equation that mimics, let's say, this rational expression. Okay, so bear with me a second and see if you can follow along with what I just wrote. So how did I get a sub 1 equal to 2? Okay, I see the geometric series here. A sub 1's in the numerator. That's what my formula says. A sub 1 is the numerator. So a sub 1, I'm going to say, is 2. Okay, great. Next, how do I get this piece? Well, look at the formula. The formula says 1 minus r. There's my r. There it is. 1 minus, you don't see it? There's the r. R is equal to x squared. Okay, fine. How do I get the rest of my terms? I want to write this out as a summation, but I want to expand it. I want to see each individual term. How do I do that? I take my a sub 1 and I multiply it by r. That's how I'm going to get a sub 2. And then again, I'm going to multiply it by my r. And then again, I'm going to multiply it by my r. So watch what this looks like. Okay, so I know I wrote a bunch of stuff. See if you're with me. How do I find a sub 2? I take the previous term, okay, a sub 1, I multiply it by my r, and I've got this. How do I find a sub 3? I take my previous term, see the connection there, and I multiply it by my r. Now there's my a sub 3. How do I get a sub 4? I take my previous term and I multiply it by my r, and I get 2x to the 6th. Okay, one more time. How do I get my next term? I take my previous term and I multiply it by x squared, which is my r, to get my new term. I didn't do anything fancy. Once I know a and r, I should be able to get each term because it's a geometric series. I get how those work. Okay, so I erased our terms to give myself some space. Look at now how I've written out this polynomial. Why am I writing it like this? I want to write it as a sum. So a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. Why? Well, right here, it tells me. Find the first 4 terms. Got it. 1, 2, 3, 4. And find the general term. What does that mean? That means what comes here. What is this pattern leading me to? Okay, so I've written a little bit. Obviously, each term has a 2, a 2, a 2, a 2. So there's the 2. Each term, remember I multiplied when I had them written out, I multiplied them all by an x squared, by an x squared, by an x squared. That was my r. So there's my r. But I need an exponent there. So I got to come up with, is that to the nth power, to the nth plus 1 power? What is my exponent? Okay, so the first term doesn't have an x squared. So really, when I plug in a 1 into my exponent, I need this to be something to the 0 power so it drops out. Think about what I just said and why is this n minus 1? Because now when I plug in, here's my first term. When I plug in a 1, so if I plug in a 1 here, 1 minus 1 is 0. This is gone and my first term's just 2. Yep, check. When I plug in a 2 here, 2 minus 1 is 1, so this becomes x squared to the first power. Second term, x squared to the first power. Check. Okay, and so on and so on. When I plug in a 3, 3 minus 1 is 2. Check. When I plug in a 4, right, if you still have that list out, check. Okay, and there you have it. This is the power series. It's called the power series expansion for that rational expression, which is really of the form of a geometric series. Done. Okay, here we go. Another example, same directions. And we want to write and come up with a polynomial that will resemble what I've got here. okay, in terms of its shape and its properties and all that kind of stuff. Right now, I'm looking at a rational expression. Maybe you're seeing a geometric series. Either way, I want a polynomial equation. So what do I need to do? I need to find my A. I need to find my R. Okay, maybe this one's a little harder to see it, but take a second, pause the video, and ask yourself, what is my A sub 1? What is my R? Okay, let's see how you did. I found A sub 1, that's the numerator here, to be x squared. Did you? This maybe is a little sneaky because my formula in a geometric series has to be 1 minus r. So maybe you had to rewrite it as 1 minus a negative x. But either way, negative x, that's my r. So I don't want to write each term out individually. I'm going to try to just start expanding this polynomial equation. So p of x equals, okay, so see if you're with me. X squared, that's my a sub 1, plus a sub 1 times r. Okay, I need to clean this up now. If I multiply those two pieces together, I'm going to get a negative x cubed. So now I'm going to multiply my negative x cubed. I'm going to go ahead and put parentheses around it by my r. So what am I going to get there? If I multiply them out, I'm going to get a positive x to the fourth. So now I need to take x to the fourth and multiply it by my r. Okay, let me clean this up for you. Okay, a sub 1 multiplied by negative x, a sub 2 multiplied by negative x, a sub 3 multiplied by negative x, a sub 4. Again, why did I do that? Because I'm trying to make this geometric, right? A geometric series, which ultimately then expanded out is giving me this polynomial. So term 1, term 2, term 3, term 4. This part, check. What's my general term? Well, my general term, it's definitely alternating here, so I have to put the alternating part in. The only part that I have to think about with the alternating is what do I want to do with the exponent? Okay, and it all depends. Do you want your first term to be positive or negative? In order to get my first term to be positive, I need an exponent that will, when I plug in 1, okay, either make this raised to an even power or raised to the 0 power. I'm opting to start it at the 0 power. So 1 minus 1 is 0. Anything in the 0 power is 1. That's going to give me a first term that's positive. When I plug in a 2 for the second term, 2 minus 1 is 1. So to the positive 1 power is going to get me a negative term. Okay, great. When I plug in 1, 2, 3, so when I plug in a 3 here for the third term, 3 minus 1 is 2. Anything squared, it's going to be a positive 1, and so on and so on and so on. Okay, so now I've got the alternating part, but I still have to know how do I get x squared, x to the third, x to the fourth, x to the fifth. Oh my gosh, what is that? So look what we have here. This x squared, in fact, I could circle it in blue and tie that in. This is my a sub 1. So let's not freak out about that. On the previous example, look back. We had a 2 there. Why did we have a 2? Because it's the first term. So this is my first term. This is my r. I just don't have the negative there because I already dealt with the negative there. So this is my r here, except for the negative, right? There's my x, there's the x. So this exponent really should match that exponent. I guess it doesn't have to, but I think it should. Because again, my first term is just x squared. I don't want an extra x in it. So this, when I plug in 1, has to give me a 0, so this term's gone. So a sub 1, okay, just this. A sub 2, this factors in and this factors in. A sub 3, this factors in and this factors in. So play around with it. Pause the video if you have to. Make sure you understand where all these three pieces come from and how they give me my general term. Okay, next up, are we getting better at this? Are we feeling better? Same idea. Here's my rational expression, which mirrors the geometric series, but I don't want that. I don't want a rational expression. I want it to be written as a polynomial. So now we're feeling all cocky about this. A sub 1's 4, right? Or is it? Look at the bottom. Do you see 1 minus r in the bottom? No, I don't even see a 1. So we need to do some manipulating. Okay, sidebar with me for a second here. Remember, this is completely random, has nothing to do with this right now. Remember when we had something like this and we wanted to integrate it and we knew it was arctangent, but we didn't have the 1 here. So what do we have to do? We had to force this to become a 1, right? So first I'm going to take the 3 out, and then I got to divide out the 4 on the bottom. I had something ugly like that. Okay, fine, pull the 4 out. But then I take this x squared over 4 and rewrite it as x over 2 quantity squared, and there's my u sub. Remember doing this? I'm going to do something similar with this, and I want you to have this in your head so that you're going to be able to follow along. Okay, so bringing it back to this, see if you followed what I did. First of all, I rewrote it where I just kind of flipped the order of the terms here. I wrote it as 2 plus x squared. Okay, what's my next step? I'm going to factor out that 2. So factor out that 2, what does that get me? That gets me the 1. Okay, but unlike the integral, I don't have anywhere to put that 2. So maybe you look at this and you say, I can reduce the 4 and the 2, or what I was going to do was I was going to divide the top by 2 and divide the bottom by 2. Okay, if I divide the top by 2 and the bottom by 2, I'm not really changing its value. I'm really dividing by 2 over 2, which is 1. So let's see what that does for me. Okay, that turns my f of x into 2. Remember, 4 divided by 2 is 2. This one's gone. 2 over 1 plus x over 2. So now I've got the 1 there. Now I can say this is my a sub 1. But remember, this has to be 1 minus r on the bottom. So what am I concluding? My a sub 1 is equal to 2. And my r, right, if I write this as 1 minus a negative, here's my r, negative x over 2. Okay, I'm not sure if I can do this all in my head, but I'm going to try for you. Let's see if we can come up with our p of x. So our p of x is equal to a sub 1 plus a sub 1 times my r plus my previous term, okay, I'm going to have to clean that up, I guess, times my r. Okay, a sub 1 is 2. Multiply my a sub 1 times my r, I get negative x. So now for my a sub 3, I have to take my previous term, which is the negative x, multiply it by my r. I get this. Now to find a sub 4, I take my previous term, okay, and I multiply it by my r, and I get this. So again, let me clean this up. Hopefully you cleaned yours up as well. Does yours look like mine? A sub 1, a sub 2, a sub 3, a sub 4. So dot, 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 but I need the general term. So what am I seeing? I am seeing positive, negative, right? Positive, negative. So it is definitely alternating. So what does that tell me? That tells me that I need the negative 1 to either the n plus 1, the n minus 1, something. Since I want my first term to be positive, I don't want that negative 1 there. I'm going to start this at n minus 1. Okay, great. What comes next? Next, I need my a sub 1. So my a sub 1, I'll go ahead and put it in blue for you. Again, that's just 2. Okay, what do I need next? I need next my r raised to an exponent. So I'll go ahead and put that one in green so that maybe we can follow this. So that's going to be x over 2. Okay, remember, I've already taken into account the negative here. So here's my r. If the negative goes there, the x over 2 goes here. But I need an exponent. So what exponent do I want to put on it? Well, I'd like it to match this one. Since these really are both my r's split apart, I'd like them to have the same exponent. So let's put that on there, and let's see if that's going to work. Okay, how do I know if it's going to work? Well, let's plug in 1. If I plug in a 1 here, this term's gone. Okay, check. This is there. If I plug in a 1 there, this term's gone. So I just have 2. Check. If I plug in a 2 there and there. Okay, 2 minus 1, that's 1. So all of a sudden this becomes negative 1, which there it is. Check. Okay, 2 minus 1 is 1. So x over 2 times 2, the 2's will cancel. It leaves me with just x. Check. I could plug in n equals 3 on both, and so on and so on and so on. And there you have it, our new polynomial equation. Okay, look at, even though you see fractions, those are just numbers on the bottom. This is a polynomial equation that's going to closely resemble that rational expression, which is in the form of a geometric series. All right, last example. Can you do it yourself? Can you find the first 4 terms and maybe even the general term of the polynomial that closely mirrors and resembles this rational expression? Why don't you take a second, pause the video, and do it yourself first. Need a hint? Here's your hint. Force the 1 right there. How are you going to get that to be a 1? Okay, check and see how you've done so far. A sub 1, A sub 2, A sub 3, A sub 4. Notice I didn't bother reducing them. Not worried about it. I'm looking for a pattern. Ready for the last part? What's my general term? Look it over. How'd you do? There's my A sub 1. That's not alternating, so there's only 2 parts. My A sub 1 and my r to the n minus 1. And there you have it. How'd it go? Hopefully you're feeling pretty good, like you've got the hang of this. If not, rewatch a part of the video, maybe find some practice problems to try. And next class, we'll work on some of these together. But hopefully, at least, we're not going to be behind because I was gone. Sorry, I will leave this last page to you to do the number crunching, but there is a typo here. Okay, and I know I didn't quite fit the whole page on there, but this should not say 0.8 and this should not say 0.8. It should be 0.4, 0.4, 0.4, 0.4, and 0.4. So go ahead and make those changes on your packet. So sorry.